Hey everybody, welcome back to Motion Problems. Today we're going to be looking at same direction problems and there and back again problems. So it's the same process as yesterday. We're going to look at the word problem. We're going to try to sketch some sort of picture. We're going to use that picture to hopefully make a data table. And then we're going to try writing some equations and solving them. So let's take a look here. We got a train leaving town east at 80 kilometers per hour. An hour later, another train on a parallel track leaves town. It's going 120 kilometers an hour. How far from the town will the trains meet? So we're solving for distance. I have the rates for both the trains, and I know that time is an hour apart from each other. So let's start with the picture. There's my wonderful town. It's a circle. Train 1, 80 kilometers an hour. Train 2, 120 kilometers an hour. 1 hour later. Distance, in this case, is the same. So, train A left the station. Train B caught up with the station. They traveled the same distance. So if I catch up with someone, I've gone as far as they have. That's key to understanding these because distances are going to be the same for these types of problems. That's going to be the theme throughout all of today's problems. Okay? So opposite direction, the distances were not the same, but they kind of added up to something together. Here we have situations wherein I'm either going somewhere and coming back, or I am going somewhere and someone's catching up to me. Okay? And ultimately at those points the distances become the same. So rates are 80 and 120. I know that time was 1 hour off. Now I'm going to write that as t for the fast train and t plus 1 for the slow train. You could express it the other way around. You would just have a negative. Like if you wanted the slow train to be t, then the fast train would be t minus 1. And sometimes you do that. This particular problem, it's not super useful because it's actually asking for distance. I will mess around with which one is t and which one is t plus or minus something if I am solving for a specific time. So if I wanted to know the time of the slow train, I would make that t. In here it doesn't matter, so I just avoided the negative. Okay. A lot of people get messed up by that, and that concept of you can manipulate those variables however you want is something that you're going to have to grow into over time. Now, the distances are the same. Distances are the same in all of these problems today, so it kind of sets ourselves up for a system of equations that we would solve with equal values method. So we got y equals 80 times t plus 1. We got y equals 120t, and we're going to solve that by setting them equal to each other. 120t is 80 times the quantity t plus 1. Distribute to both terms. Don't leave off one of the terms. Subtract the 80t off. You got 40t equals 80. You divide by 40, and you end up with t is 2. But the problem asked about distance, so you're not done. You can tell you're not done because Mr. Waddell didn't write time equals 2 hours and call it a day, right? Time's still 2. I don't put units throughout problems because I find that it makes things really messy. I usually just put the units on at the very end. So I can take that time equals 2. I can go back to either equation because we know the distance is the same. And I can substitute the 2 in and solve for 240 kilometers in this case. I got a car that's leaving Hartford, traveling north at 56 kilometers an hour. Another car leaves Hartford an hour later, traveling north on the same road at 84 kilometers an hour. How far from Hartford will the second car overtake the first? Hint, the cars go the same distance. Whenever someone catches up to someone else, they went the same distance. When you see a problem that is about catching up to each other, they went the same distance. Draw a picture here. 56 kilometers an hour for one of the cars, and the other car is going 84 kilometers an hour, and it left an hour later. I am once again solving for how far from Hartford, so I'm solving for the distance. I know the distance is the same. We got 56 and 84. I got t plus 1 and t. And distance is the same. So distance equals 56 times the quantity t plus 1. Distance also equals 84 times t. So I can set 56 times the quantity t plus 1 equal to 84t. I'm going to take my two equations. I'm going to combine them with the equal values method. And I'm going to solve. I'm going to start out by distributing the 56. I'm going to subtract 56t off the 84t. And I'm going to divide by the 28 to find the t is 2. But I'm not done. I'm not done. The problem is asking about distance. I got to go back. All right. I take my time as 2. I plug that into either equation. They both have the same distance. So distance is 168 kilometers, it turns out, because that's what 84 times 2 is. Easy. We got a motorboat. It took 3 hours to make a downstream trip with a current of 6 kilometers an hour. The return trip against the same current took 5 hours. Find out the speed of the boat in still water. Okay. If you've ever been on a boat or seen anyone boating, you know that ultimately there's this thing called the current. It is the force of the water as it's moving. Okay, so the water is moving. It's moving downstream, right? You are either going with the current, in which case the current is making you move faster. The current is adding to the speed of the boat. Or you're going against the current. If you're going against the current, then the speed of the water is subtracting off of your boat. So with the current, the boat is going r plus 6. So it's the rate of the boat plus the current. Going against the current, it's the rate of the boat minus 6. So I add the current and I subtract the current, depending upon whether I'm going with it, positive, or against it, negative. So I got r plus 6, r minus 6. I was told 3 and 5 were my times. Distance is going to be the same because I went there and I came back. I went somewhere and I came back. So we got 3 times the quantity of r plus 6. I got 5 times the quantity r minus 6. My two equations. It's equal values method time again. Distance is the same. So those two quantities equal each other. I distribute, and then I'm going to combine some like terms. I move the 5r over. I get negative 2r equals negative 48. I divide by the negative 2, and I find that r is 24. So the speed of the boat in still water is 24 kilometers per hour. And there's a really nice way to answer these problems with a complete sentence. I don't always enforce that. I do always enforce units. If you don't have your units, you're wrong. Sometimes I will ask for the answer as a complete sentence, though. One last one here. We got an airplane, and the airplane's going to do the exact same thing. The airplane flew for 5 hours with a tailwind of 25 kilometers an hour. The return flight against the same wind took 6 hours, and I want to find the speed of the plane in still air. This works identically to the boat situation. The only difference is it's an airplane dealing with wind versus a boat dealing with a current. Okay, so they're both going to be the situation wherein I'm going to add this tailwind of 25 kilometers an hour. I'm going to subtract the tailwind. So draw the picture there with the tailwind. I have an r plus 25. With the headwind or against the wind, I am r minus 25. Throw that into some tables. We're told the time is 5 and 6. Distance has to be the same because I went somewhere and I came back. So I got two equations, two unknowns, and they're an equal values method. So I'm going to make them equal to each other. Going to distribute across. So 5r plus 125 equals 6r minus 150. And I subtract off the 5r from both sides. I add the 150 to both sides. And I find that the rate is 275 kilometers per hour for the plane in still air. And that's really about it, folks. That's how you solve these motion problems. Ultimately, pay attention to what you're being asked for. Pay attention to the setup. They're not terribly hard problems, but getting used to the language can be a lot for people. So please take some time and really try to practice them. Don't just blow through it so that you can go on to the next thing. If you do, you won't get used to these and you'll think they're really hard. Okay? If you're finding these things are really hard, practice more. If you don't, they'll stay hard forever. Okay? If you do, then they become kind of easy and really not that hard. That's my advice to you. Hope you have a great night, and I'll see you in class tomorrow. Bye.